All right, officially recording and starting. Welcome back, Zoomers. When will they be available for purchase? I haven't made that additional step, but if enough of my multitudes of subscribers really insist on having merch, maybe we can crowdsource this. Multitudes. My son makes fun of my YouTube channel because it isn't as engaging as some of the ones that he watches, but I try to tell him that's not the point. The point is to amuse myself and to provide everyone with recordings that they can access whenever they want. So I noticed that a lot of folks are not coming to class on a regular basis. I don't intend for the recordings to necessarily substitute for that, although that is how they're being used. I would say that their best use is for clarifying certain concepts and reviewing certain things as needed, as you indicate having to go back over stuff and think, I need to hear that again, or I need to read that again. But we have the recordings for posterity for whomever wants to use them. We also have formative assessment stuff to talk about, schedule stuff to talk about in Lecture 5 to start. So lots of things today. So first off, I sent you a book of an email, I think Sunday night maybe, something like that. I don't know, the days are all blended together at this point. I have updated the rest of the syllabus for this semester along with the printable version. So there's a PDF of this that's currently updated as well. And we have formative assessment number 3 to do today. Other things of note, on Thursday we're meeting on Zoom only, but it's starting late at 12:55. I had to squeeze in something else, and that was the best that I could do. Then we have homework 3, which I looked at, and a few of you have started, but not many. So please don't forget about that. That is over the accelerated time models. Less complicated than the example that I gave you, by the way, trying to take a little bit of pity on you and not have it be completely overwhelming with quadratic terms and whatnot. But that is due next Monday. You should have gotten your project outline feedback. And if you don't have it, it is inside the homework portal. There should be a link to a document. If I did not give you 5 points, that means I did not get enough information from you to clearly have a sense as to what you're planning and what I would recommend in terms of examples to follow. So the idea is that you would consult with me as needed to answer those questions. This can be a discussion. You don't have to figure everything out on your own. If you want to bounce ideas off of me or thoughts in terms of which way to take something, that's fine too. We just need to have a written agreement essentially as to what you're going to do by the 7th. That way, when I look at your presentation, I can see what I expected of you, what you actually did, and make sure that those are commensurate. So let me know if you have questions or want to talk about any of that. As we get further into project season, I'm expecting that folks will want to have more time with me than what office hours provides. That's fine. You can ask to schedule individual meetings. Zoom will be most optimal. That way I can look at your code and we can talk about things however would be most useful. Let's see, after the revisions to the project outlines, send to me by email, please. One more formative assessment, one more rumor, hello, and then a break in the action because then we hit presentation season. So we have 4 groups of presenters starting on the 22nd. You should have all seen the schedule that I put together. I believe I was able to honor all of your requests in terms of preferred sections, if not preferred dates, and to make sure that you're going to be available. In looking at everyone's availability, I realized only 3 of you or so are going to be around on the 24th, so I decided to turn that day of class into office hours. That way, folks who are presenting can have more access to me. And then we have, essentially, after each group gives a presentation, the peer reviews of those presentations are due 1 week later. I tried to make it so that no one is peer reviewing in the same session they're presenting, and to try and keep them at least a week apart if possible. I think, Erica, yours is like the closest in time, but you're working in a pair, so y'all have to figure it out. There's only 2 sets of pairs, and you're going to review each other. So everyone completes an individual peer review of someone else's presentation. Did I put that up yet? I don't think I have that up yet. So I'll put that file up in terms of what that's expected to be. I also put up, I thought I did, project, what is it? Nope, it's not up yet. I have a rubric document. I need to put that up still. So I will do that and we can talk about that on Thursday instead. And yeah, then we get to the end of the semester. So the peer review thing is the last thing that I'm expecting of you. If your presentation does not go as well as you wished it would have, you can record a video of that and send it to me as a revision. You don't have to present in front of anyone else for the revision process. So that's a lot of logistical stuff, schedule stuff. Any questions so far? Please let me know as soon as humanly possible if the date that I assigned you will not work out for whatever reason. I'm hopeful that everyone's dates will be okay since I collected the information ahead of time, but I know life sometimes interferes. And if you want to trade with somebody and you're both okay with that, then that's fine with me too. Like if you want to solve your own scheduling problems, I'm here for that. So, okay, so we're good on that for right now. All right, then let's flip over to formative assessment number 3. Any review topics? So I have collected those from this time and I've worked on adding them to the list. So I will make sure that we get through as much of that as we can. Not many folks had new things, but we have some things I think that could be useful to review from the previous comments. Question number 1. So we're intersecting the world of longitudinal analysis via multi-level models with the world of longitudinal analysis via structural equation models. And in other quantitative programs, like that's a whole class. Longitudinal structural equation modeling could be its own semester, easily. I'm trying to give you the highlights and to give you an orientation by which you can learn about other permutations of models that are available and that people sometimes use. So first question then, what is the primary difference between how multi-level structural equation models are specified and how single-level structural equation models are specified? I'm gonna do this in stages so we don't talk till we overtalk each other, okay? So I'm going to the Zoomers first. Talk or type to me. What did you write down? Dun, dun, dun. See, rumors, you can get your answers prepared or finish chewing, whatever you need to do to answer the question, it's fine. We have MSEM is long form data. Yes, so long format, otherwise known as stacked format, means that it is one row per occasion. For multi-level structural equation models, person dependency is captured primarily by random effects through levels in longitudinal data. Yeah, that sentence sounds familiar. For single-level models, person dependency is captured by latent variables in wide single-level data. Wide, yes. And whether or not within and between levels are specified in the code. Yes, 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 yes to all of that. So the data thing drives a bunch of downstream consequences, and that, I think, is the thing to hang on to. So not having everything be on one level, so to speak, without the between and within makes it a lot more challenging to figure out what is a between-person source of variability, what is a within-person source of ability, because you kind of have to know what you're doing without making it obvious. The long versus wide data controls what you have access to at the same time. So I have one of the things on your reading list is a chapter and a handbook that I just finished. And this is the one that has the Rosetta Stone title that someone made me have, and I subsequently decided that was a good title and I took it, but I didn't know what it was at first. When I was trying to find a way to explain this, I ended up thinking in terms of the spreadsheets that I normally make in class, and so I made a nicer looking version that's a table. So in terms of distinguishing multi-level modeling from single-level structural equation modeling from multi-level structural equation modeling. So the traditional one means univariate, meaning you're only able to predict one column in your data set, but that's okay because each row is a separate occasion for a separate person. Single-level SEM is wide data format where it's one row per person, so each of your occasions must be stored in separate variables. And then multi-level SEM combines these two in that it allows you to predict more than one column, but you're doing so in stacked data still. So this one I would say is the most general in some respects, but the fact that occasions are on separate rows then has some limitations in terms of what you can do for models. So for instance, how is unbalanced time represented? Well, if you're in stacked data, you have a column for time, and it can be balanced or it can be unbalanced, and there's no consequence to that. In SEM, if you have unbalanced time, you have to make sure that your software can understand that. So a few of you wrote about this in relation to a later question, I think advantages and disadvantages, but we can cover this here. Because you have to have a separate column for each separate occasion in wide data SEM, you're presuming that your data are balanced. Like you have, this is my column for time 0, this is my column for time 1, this is my column for time 2. Definition variables are subsequent columns that would keep track of exactly when time 1 was and exactly when time 2 was. Another rumor, hello? And to the best of my knowledge, the only SEM packages that have this capability for definition variables are the OpenMX suite within R. It used to be a standalone thing, now it's implemented in R, and M+ with t-scores. There may be others, but I have not come across them. So I think if you have unbalanced data, I would probably shy away from this as an alternative because it's going to be less flexible. If you have balanced data, you can kind of do whatever you want. Okay, with me so far? Any questions on any of that? Okay, so then how many outcomes can be predicted? This then has consequences for what happens to missing data. So because we can predict more than one column, we can predict more than one outcome. We hack that into turning predictors into outcomes, and then they can have missing data so long as you're willing to make distributional assumptions. So it's not for free, but it is additional flexibility because we're trying to essentially find the means, variances, and covariances for what used to be predictors at the same time as you have for your outcomes. So that gives us flexibility. How sources of between-person correlation are captured for each outcome. This is a semantic distinction, to be quite honest with you. Random effects is what we call it in anything multi-level. Latent variables is what we call it in anything SEM, but it's 6 of one, half dozen of the other. That's a separate question. Let's see, how sources of between-person correlation across occasions are captured for each predictor. This is not a semantic distinction. So if you can only predict one outcome, is the case in standard univariate multi-level modeling, then you have to build observed predictors to partition the variance in your time-varying predictors into between and within. So that's where we would do something like person mean centering. We would have the person mean at level 2 to capture the between stuff. We would have the within person deviation from that mean at level 1 to capture within stuff. We can do that using latent variables in multivariate software either way here. So that's an important distinction. Missing data, then, we talked about that, follows that. And then types of estimation, that gets into advantages and disadvantages. So this is table 1 in chapter 21 of the handbook that goes with the reading for this, if you're interested in taking a look at that. Okay, let's go back to formative assessment land. So wide versus long data, I would say, is the big one, and explicit differences of between versus within that happen in anything multi-level that don't in anything SEM. Okay, any questions or comments on that? Okay, make sure that I'm getting, making sure I'm answering my question, that your questions at the same time here that I wrote down some notes about. Okay, so number 2 then, what would be some advantages of setting up your longitudinal analysis using some kind of SEM or MSEM software? When might you want to go that route? I'm going to start with, I started with Zoomers last time, I'm going to start with Roomers, who have tripled in number. You have. There's 3 now. Okay, what are some advantages? When would you want to buy your growth model at the SEM store instead of the MLM store?
If you want to predict more than one thing, whether that's missing data or something else.
Yeah, if you want to predict more than one thing, broadly construed, which would mean if you have predictors that have missing data, if you have multiple outcomes that you want to see at the same time. What's another instance in which multiple things at the same time would apply? Yeah, like what you're planning on doing, right? Yep. What are you planning on doing? Talk louder.
I'm trying to measure this state characteristic using different sources of data from like immigration, child welfare services, incarceration and stuff. So trying to measure an unobserved latent variable of all of them.
Yes, so some kind of unobserved state level latent variable that has indicators, and they might change over time, right? Potentially, but there's overlaps, you're cool. And then you're going to see how that latent variable itself grows. Yeah, that would be a good reason to use SEM anything, because you can't really have latent variables if you can't have more than one outcome. But that's part and parcel. I think that's a separate question to get onto, curve and factors and factor of curves, so I'll just let that one be for now. Let's see, what else? What other instances in which you might want to predict more than one thing? Several of you have an example of this in your projects. I'm going to call on Erica and Ahmed. You have some kind of level 2 outcome, right?
Yeah,
Whether they pass an exam or something like that?
I believe so.
Some,
But it's like a binary, I think.
yeah, so you have something that's growing over time, and the individual differences in that growth are then going to predict some downstream consequence, almost called a distal outcome in a lot of contexts. You'll see that phrase. Yeah, that would fall under the predicting more than one thing. In that case, if you have a level 2 outcome, so something that is measured once per person, like whether they eventually graduate high school, whether they eventually pass some licensure exam, something like that, then logically speaking, things that vary over time cannot predict that outcome. Like how you are today isn't going to predict whether you graduate high school. It's the person level information that is absorbed or contained in the time varying stuff that's going to do that. It's like people who started out lower, people who changed more, they're more likely to graduate high school or they're less likely to graduate, that kind of thing. So you can't have intra stuff predict inter stuff. It's the inter within the intra that does the prediction. And yes, I have to do the hands because this is the between and the within. That's another one. Am I forgetting anything? So advantages largely stem from being able to predict more than one thing at the same time, extending to latent variables, predicting distal outcomes at level 2, predicting using latent variables as measurement models underneath this. Anything else we're forgetting? No? That's all I had on my list, I think. Let's see. Disadvantages then. Why wouldn't you want to do it that way? It sounds wonderful, doesn't it? Until you have to do it. That is a valid concern. I don't know if you've looked at example 5A yet. I just posted it for Thursday, and yeah, it's a lot.
I looked at it and then I frowned
And then
put
you,
it away.
yeah, you put it away. That's fair. How do you think I feel when I look at it? I'm like, oh Christ, I have to explain this. Yeah, that's why there's comments next to everything, because like future me was like, no, I'm not going to be able to keep this straight without literally writing all the answers out. So that's for you and for me. Yes, it is more complicated because there's less transparency, I think, because there's just so much complexity of what's happening, especially when you get into the mixing of latent variable measurement models with all of this stuff. So yes, it's harder. That's one disadvantage. What about small samples? How does that interface?
No REML.
Yeah, no REML. And along with that, in terms of what is offered in software, no denominator degrees of freedom. Everything is going to be t's and chi-squares in SEM land, which assumes infinite sample size. What is Bayes going to fix it? No, not necessarily. I think Bayes will give you more accurate estimates of how uncertain your parameters are, because everything is not nailed down the way that we pretend it is with respect to variances, but no. That will make it actually probably more complicated, because then you have to worry about priors and convergence and that stuff on top of it. So Bayes can be helpful, but it's not necessarily a panacea. What else? How about balanced time versus unbalanced time? Mentioned that earlier. Okay, we're going to go to Zoomers now. Let's keep spreading it back and forth. Zoomers, what do you think about disadvantages related to time, balanced versus unbalanced? No one wants to talk, but I'm watching the chat.
They require balanced time, otherwise they'll smush the effects.
Otherwise, you're rounding time essentially into convenient intervals. Yeah, unless you can tell your software it's not doing that. But I have had models that wouldn't converge in M+ if I did them unbalanced that did converge when I did them as balanced. So it doesn't always necessarily work. It depends on the complexity of everything else. But yeah, that would be a big one to me, is that if you have balanced time, you have a lot more options in terms of what you can do regularly. Unbalanced time really does need that time column to keep track of when people were measured exactly. Question?
But you could use MSEP and still have the right, and
Yep.
that would, you just couldn't use the single level SEM.
Correct. Yes, you could
Okay.
still use MSEM because that's long data in which you'd have a time column, but you couldn't do the single level SEM. Yep. Unless you had the T-scores.
For myself, who might have to do that.
Yes, and I just went through the state of documentation again, and I didn't see anything related to that. So it may be hidden in there because the SEM documentation's like 700 pages long. I'm not kidding. Like I went through the examples to try and build a path model for y'all in example 5A, and I got to like example 42G as as one of them. Yeah, and it didn't work. So I copied it exactly, and it didn't work. I'm like, yeah, done. Yeah, I know. At some point, you just got to give up, you know? All right, those are the ones that I can think of. Less transparency, easier to smush, more difficulty in modeling unbalanced time in single level SEM. Those would be my disadvantages. And no REML and degrees of freedom for a level 2 sample size. Question 4 then. How are fixed and random effects operationalized or specified within SEMs? So what is the translation into what we would typically call a fixed effect, like a fixed intercept or a fixed time slope? What would that become in this way of thinking about it, the SEM world? We'll go to, let's see, didn't get any answers. We got one answer out of but there's more of you. So I'm trying to do this balance thing. We've got 6 of them, 3 of you, so that means you get 2 turns to your 1 turn. Okay. Zoomers then. What is the analog to what we would call a fixed effect in multi-level world in the SEM world for longitudinal? That's the question.
Isn't it like the mean of the latent variable? For
Yes.
The latent variable?
Yeah, the mean of the latent variables, that's what it is. Exactly right. So then, rumors, what's the analog to random effect variances? What do those become in the SEM world? The variance of the latent factor. Yes, latent variable, latent factor, latent trait, theta, what I don't care what you call it. Take your pick. The circle. And in the MSEM world, they still show them in circles, but it's much more direct. Like people talk about them as random effects at the between level and residuals at the level 1 level. But for whatever reason, they switch to latent variable terminology sometimes in the MSEM world and almost all the time in SEM world. So it is 6 of one, half dozen of the other. The connection is that what we used to call placeholders, like the beta 0 and the beta 1 in the level 1 equation, that's your latent variable. And so then that contains the mean and the variance as well as whatever other fixed effects are going to predict that beta 1 or that beta 0. So that's the connection. Yeah. I think that's all I wanted to say about that. So latent variables / random effects are still in your G matrix. The residuals in the within model or the residual variances of your observed occasions in single level SEM, those are your level 1 R matrix. And Z are your factor loadings or your time variables. Last one, curve of factors versus factor of curves. First off, are these synonyms? They are not. They are 2 different things. And I cannot answer this question myself without putting the picture in my head. So I have to talk with my hands and my eyes closed to answer this. And feel free to do the same thing if you need to. So first off, what is a curve of factors? I think we're back to Zoomers. Are we? I think so. Whatever. I'm trying to be fair. What is a curve of factors model for?
Determining how one latent variable changes over time.
Yes, so you're thinking of your multiple outcomes as indicators of one thing, and you want to see if that one thing changes over time, and then what predicts its changes, and potentially what it predicts in terms of its changes and all that kind of stuff. And could you have 2 latent variables? Like, could you have indicators of like depression and indicators of anxiety and see how they all both change? Could you do that? Sure. Could you have 3? If you wanted to. Would I recommend that for your project? Probably not. 1 is enough. Just 1. Yep, so the idea then is that your multiple outcomes are thought of as representing one idea, and you want to see if that one idea is what's changing. What is required for that to be plausible?
Your factor has to like be the same throughout, like it can't change. So that means that the slopes predicting it kind of have to be in the ballpark of the same.
Yes, the factor has to mean the same thing over time, which is operationalized in terms of three different things related to the factor, right? Same latent variable over time, yes, good Zoomers. So the slopes in that world are called, starts with loadings, yep. And then the intercepts and or thresholds, if you have some kind of categorical model, those need to be the same over time. So if the loadings are the same, then most people would say that means this trait is defined similarly in terms of it's more of this, less of this kind of thing. If the intercepts are the same, that means that your outcomes have the same expected value at the same level of the factor, regardless of what occasion it is, and that should be the case. In other words, the reason that your indicator means may have changed over time is because your factor mean changed over time, and that sort of trickles down to the indicator level. That's the rationale. And if you have, the last one then is residual variances, and that's probably less important, but it's part of the process. So once you can sort of glue your factor together over time with these constraints, then you can see if your factor grows. What if you don't have the same indicators at each occasion? Is that okay? Yeah, what if you have some in common?
That's okay.
That can be okay. Technically speaking, mathematically, you need one indicator to hold it all together over time, but that would be a terrible idea. So at least partial invariance. We could say maybe this indicator is more important at the first occasion than at the other occasions or something like that, or this indicator's intercept wants to be different at this occasion, like that is still fine. But if everything sort of falls apart in terms of your invariance constraints, then maybe it's not reasonable to think of it as one thing that grows over time, and you'd want to do the opposite. Factor of curves. So this is, the basis of this is a multivariate model where you would have multiple intercepts and slopes at the same time, and you could see how correlated those are. That's enough, honestly, for a project like that. That aspect would be fine. A few of you are doing that, I think, looking at how people who start out higher in this outcome, do they also start out higher in this other thing? If you grow more on this outcome, do you also grow more on the other thing? Like, those are interesting questions. If you have at least three outcomes, you could ask, are the correlations among the intercepts consistent with the latent variable? Are the correlations among the random slopes consistent with the latent variable? And so then you would have two higher order factors that explain the covariances among your random effects, that explain the covariances among your indicators. Yep. And so example 4 has code in M+ to do both of these things, if you're feeling like that might be fun. So partial invariance is required for the first one. It is not required for the second one. All right. Looking through my notes here. So one question then that I haven't hit yet, why is MSEM better for time-varying predictors than univariate MLM? This is going to be some foreshadowing into lecture 5. We're going to start talking about that.
Can you repeat that?
Yeah, the question was, if you have time-varying predictors, when would MSEM be better for that than standard univariate MLM? That was one of the review questions that folks wanted to talk about.
Is it if you have more than one time varying predictor? Or no, the time varying outcome is what we had done.
We had done time-varying outcomes. We had done time-varying predictors. And let me foreshadow the answer here. Okay, so lecture 2 and example 2, the content of that was labeled time-varying predictors of within-person fluctuation in univariate MLM. That's your foreshadowing. When the time-varying predictor changes differently over time, ding, 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 that's it. So that's what we're heading into now. is this idea of person mean centering is ideal for time-varying predictors that do not change. Because you're talking about if one tends to be higher than other people on average, here's your between, this happens. On days when you're higher than your usual, this is what happens, there's your within, right? Nice and tidy. And if you had only been through like clustered multi-level modeling, you'd be like, yeah, I'm done, that's it. But what happens if the time-varying predictor changes itself? Like X itself has individual differences and change. That's still buried in what we used to call within person. And that's a whole separate idea. So if X needs a random slope, that's when we have to switch to some kind of multivariate model to be able to get it. So this is like age versus stress, right? Maybe, can you say more?
Yeah, I was just thinking like, because age will change the same for everybody, whereas stress might change differently. Is that correct? Okay.
Yeah, and actually the last time I taught this class, I had it reversed. I did the accelerated stuff first for that reason, and then I did the person mean centering stuff, and it went very, very badly. The idea of like cohort as contextual effects was really important, I've learned, in trying to cement that down. But yeah, so when we fit the accelerated time models in example 2, and what you're going to do in your next homework, there is between person variance and age that results from people starting the study at different points. There is within person variance and age that results from people getting older during the study. But that's it. Like there's no other possibility. Whereas if I think about something like stress measured, like say every year for adolescents, right? Some kids may have more stress all the time. That's one kind of between. Some kids may increase systematically in their stress or decrease systematically in their stress. That's another kind of between. And then even after that, so long as you have at least 3 occasions, why are you off your line today? What happened today that made you extra stressed even after I gave you your own intercept and slope? That's within. So just as we think of for any time-varying outcome, could have individual differences in intercept, individual differences in changes of various kinds, and residual stuff going on, it's a semantic distinction with respect to what's a predictor and what's an outcome. And so this is, I think, something that's not well understood. I've written some stuff about it lately because I keep getting this question and I wanted someone to have something to read that explained it. And so that's what we're going to be talking about, is then the transition from univariate thinking about time-varying predictors into multivariate. Because in the clustered class, we don't have to deal with this because time isn't there. And that's what causes all the extra levels of complexity. So that's why. Also, missing data. So if we go back to the table here, if we think about the differences across these and what happens to missing data. So let's say that I'm going to do a typical approach to time-varying predictors in univariate MLM, like we started with. I'm going to make a person mean, and then I'm going to make a person mean deviation. Cool? We good with that? In theory, right? Now, what if somebody has only 7 out of 8 observations? We make person mean out of the 7, right? And then the 8th one wouldn't be in the model. Well, what if we're adding another time-varying predictor where they did have an observation that week, but they missed the other one? So then their person mean is based on a different set of weeks. And then it's like, well, if I'm going to have to drop out weeks 7 and 8 anyway, should their person mean be based on just only 1 to 6, or should it include the ones that we have that aren't going into the model because of missing data? And if you're like, what? Yes, exactly. And if you end up with different answers based on which occasions contribute to your person mean, that is likely indicative of informative missing data that should not be ignored. Like if the story changes, then there are reasons why those occasions are missing. So if you're in that sort of Swiss cheese from hell grid of this one's missing hin, and this one's missing then, this one's not missing, and this one is, when you're trying to figure out which occasions are all going to stay in your model, quit. Go to MSEM. Treat them as outcomes, and then you can have a random intercept that represents the between based on whatever data you can feed into the problem. You don't have to make these arbitrary decisions about what rows to drop based on listwise deletion. Okay, I think that hopefully that answered the questions. Trying to look through my list here. We had a request to go over MCLUS code for wide format data. We will see that in example 5A as well, so I think I'll hold off on that one for right now. Anything else that this is bringing up for y'all that you want to discuss? Yep.
Okay, so with the missing data, so you bring an SEM world,
Mhm.
you bring it into the joint likelihood by making it a outcome. So then,
Yes.
like in the case of my project, there's a couple states that don't have data on varying things. So if I use like state characteristics to then like predict that outcome, that's bringing it to the likelihood?
Yeah, so the idea of bringing a predictor into the likelihood so it can have missing data, at a minimum, it's like you're estimating an empty model for it. You're giving it a mean and a variance. That will go better, I think, if it is actually an outcome, because you can't use link functions and have empty models for predictors. That doesn't work like with an M+. You have to actually make it an outcome in that case. But yeah, if you're predicting something, then it is an outcome. If you ask the software to estimate a mean or a variance or a covariance for it, it's tricked into becoming an outcome. And in certain SEM packages that are older, you don't get a choice. So like in the SEM version of Stata, if you say you want estimator equals FIML, it brings everything into the likelihood in your model, whether you want it to be there or not, everything. In M+, you can choose whether it's a predictor that's not in the likelihood. That means you don't have distributional assumptions, but you can't have missing data, or it is treated as an outcome, and you can have missing data at the cost of distributional assumptions. Lavon has both. It used to work like Stata, and now it's added something to makes it look like more like M+. So you get a choice in that. If you do SAS, does anyone use, what is it, Caelus in SAS? That's a really old SEM package. That works like Stata. It brings everything into the likelihood if you say FIML. So it takes some detective work sometimes to figure that out as to what is actually happening. Did I answer your question? Maybe?
Yes.
Okay, empty model, that's the answer.
Okay.
Yeah.
I don't have to ask you more questions.
Yep, that's fine. Yeah. By asking for an estimated parameter for its mean, variance, or covariance with anything else, you are bringing the predictor into the likelihood as an outcome. And don't ask me what happens in Stan, because I don't know. Magic happens in Stan. I will never understand that. Okay, other questions or things you want to discuss? All right, then I've got lecture 5 here, and it's review to start with. At least a few slides, since I shouldn't assume perfect recall of a topic that we covered 6 weeks ago. Is that fair?
When I was doing the thing yesterday, I was just like, oh my gosh, I don't know any of it.
Yeah.
It was so hard. I probably should have done it before spring break.
No.
When it was fresher, but.
Yeah, so many of you put it off until yesterday, and I actually think that was a good choice, because then like you're forcing your head back in, because otherwise you'd show up today and be like, yeah, I did this 10 days ago, I have no idea what I wrote down. So it's fresher when it's sooner. This is why, even though you're required to turn in drafts of your theses or dissertation to your committee at least 2 to 3 weeks in advance, we're not opening them until the day before. I'll just tell you that right now. A few people might read them more in front. I tend to do it about 2 to 3 days ahead of time so that I can send my feedback, but then it's fresh enough in my head that I haven't lost the plot. So yeah, I understand. Sometimes procrastination is the right choice.
Yes.
It's all about the context. Yeah, pun intended, because we're going to start talking about contextual effects. All right, let me get this slideshow up here. Fresh off the presses. I just went through and revised this from last time. I hope it will go better than it did. So we're talking about time-varying predictors again in longitudinal models of within-person change as opposed to fluctuation. So these are data contexts in which we would expect individual differences in change on purpose, because that's what the study is for. And if your outcome is something that is likely to have individual differences in change, then odds are good any time-varying predictors are going to too. So fluctuation is what I would think of if you're talking about like daily diary kinds of stuff, outcomes that change within a person, but there's no intervention, there's no systematic reason for decline or improvement like training or intervention. They're just sort of bopping around. This is the growth curve like prototypical case that we've moved into. And yes, you can have some of both, but The key idea here that's new is that what do you do if your time-varying predictor itself shows individual differences in change? And what happens if you ignore that and misspecify your model? So we'll talk about what we used to do and what the problems are, and then get into the idea of multivariate, and I want to talk about 3 example use cases as listed here. So this will take a while to get through, only 45 slides, but make it. You'll note that on the syllabus it says TBD for a couple days, because I'm like, I have no idea how long this is going to take, and we're going to find out. So remember, within person, between person, and contextual and smushed. Remember those words? Okay, so let's fill in our minds with what the word means. So if I have a time-varying predictor, there are a couple things I might want to know about it. First off is the obvious one. Is there a within-person relationship of this predictor with my outcome? What that translates to is if I have a higher predictor value than usual at this particular occasion, does that show up as a higher or lower outcome than usual at this occasion? So regardless of what usual is, if I'm higher than my own expected value, does my outcome follow suit? If so, then I would expect this fixed slope at level 1 to reduce the within-person part of the time-varying outcome, which is the residual variance. So if I have a level 1 predictor, it should explain level 1 variance. What happens if it explains level 2 variance? Yeah, bad. If a level 1 predictor explains level 2 variance, that is a smushed effect. It cannot happen. The only way it can happen is because of the level 2 part that's still embedded in the level 1 predictor. If you explain level 1 residual variance exclusively, what should happen to your intercept variance at level 2? Do you remember? It goes up. It has to, because the way that it is computed is the observed between person variance minus the residual divided by level 1 sample size, where the minus residual divided by level 1 sample size part is meant to be a proxy for the expected amount of fluctuation. Like even if there was no fluctuation, what would you get just by chance? So it's trying to correct the estimate for that. If you explain more residual, you're correcting less, which makes the thing go up. That idea, by the way, will also show up in terms of why you will get different estimates for your between slopes if you put it in an MSEM attached to a latent variable than if you put it in person mean centering attached to an observed variable. There's research on that. There's a very seminal article on your reading list, Ledke 2008 and colleagues came up with that. That's a good one to take a look at. Between person then, this is the part that if you're measuring things over time, it might be easy to overlook. But if I ask you how stressed you are every day, some people are going to say they're more stressed out than others on average. There's just individual differences in levels of things that are constant to a person that stay with them regardless of what occasion it is. So if I tend to be higher on X than other people, if the person mean of my time-varying predictor is high for me relative to other people, does that show up as a higher outcome? Does that affect my intercept? And if so, then the level 2 part of the time-varying predictor should capture random intercept variance in the time-varying outcome. The level 2 part represented by the person mean is what we've done so far. Okay. With me so far then? Doing good? Okay. All right. And then the trickier one, contextual. This is also a level 2 slope, but it does not mean the same thing as between. You can think of this different ways. One way is to think about differences in what's being controlled. So a level 2 between person effect does not control for the time varying information. A level 2 contextual slope does. So contextual would be like, what is the extra effect of being someone that tends to have high person mean stress after I adjust for how stressed you are today? What's the extra component of being a stressed out person? Between is just, what's the effect of being a stressed out person, period. And in longitudinal data, because occasions are not individual units with their own identities, between usually makes more sense than contextual. Another way to think about it that's complementary is that contextual is the difference of between minus within, so it tests whether or not the smush slope is okay. And unfortunately, I would love to ignore this distinction, but SEM and MSEM software is notoriously difficult to figure out which one of these you're getting, between or contextual. So I've spent a lot of effort trying to figure this out and trying to find a way to disseminate it to explain it to you and everyone else. So that is part of the complexity in examples 5A, and what will be 5B is trying to figure out when do I have between and when do I have contextual, because it's not obvious. It's absolutely not obvious. Okay, so then what we've done so far falls under univariate MLM. Where we're headed is multivariate. And these are the terms that I will probably use more consistently. When I say multivariate, think MSEM or SEM, just any kind of software that can predict more than one thing at a time. How you then fit your model into that software depends on whether it's wide data or long data in terms of the code. But within univariate MLM, like Elmer, like mixed, we did person mean centering. This is the one that I like the best because it's the easiest to get right. You do the work ahead of time to figure out what your variables mean, and then you know what they mean, always. You build a person mean, that goes into the model at level 2, centered at a constant. You subtract the person mean from your OG version. Remember that. OG x minus person mean x gives you the within person version. So if you've removed the person mean information, all you should have left is within. So you know it has to be the within slope you get back at level 1. These two variables would then be orthogonal. So you know at level 2 you have to get the between. And if you leave either one out, you're assuming its slope is 0, just like any other omitted predictor. So that part should be relatively straightforward. I call this variable centering because the idea is the same, whether you're subtracting the person mean, the cluster mean, the state mean, the hospital mean, whatever it is. Grand mean centering, which I call constant centering because it doesn't have anything to do with the mean per se, it's just subtracting a constant, a number, is then setting yourself up for more difficulty because then you're not removing the level 2 person information from your time varying predictor. You're leaving it in there and you're letting the model do the partitioning for you. So if we have a constant centered predictor all by itself without anything at level 2, that's smushed. That's bad. If we add in the person mean, then we end up with a within effect at level 1 because you have controlled for the person information, but level 2 becomes contextual. And you can get back and forth across these with respect to the fixed effects pretty easily. Between minus within is contextual, within plus contextual is between. Multivariate then says, why are we making this out of boxes? I didn't do that for y, right? You didn't see me compute like a person mean on y and put that in one regression and then a within person and put that in another. People used to do that in the 70s before they could do this stuff though. It's called slopes as outcomes. We don't have to treat x differently than y. We can treat x as if it's another y. And that's the easiest way to explain it. The terminology goes by a lot of different names, but latent centering is the one that seems to have caught on. And it's the idea that you let the model do the centering for you. You let the model figure out how much of these variables are between, how much are within, and estimate the effects using latent stuff instead. So in terms of a picture, person mean centering would look like this. So on the x side, we have boxes, meaning an observed person mean that we're pretending is perfect, an observed within person deviation from that mean that we're pretending is perfect, and they each get their own fixed slope. Y, meanwhile, is carved up into intercepts and residuals. If we have constant centering, it looks like this, except that we have level 1 contributing to level 2 as well, and then the contextual fills in the difference to get to what between would be. And these things are correlated, which means their effects are different when they're apart than when they're together. So, this one. Can you guess where we're headed with this? Can you guess what we're doing differently in latent centering? Circles, yeah. Circle here, circle here. Now this picture is consistent with a within-person fluctuation kind of model, right? There's no time in the picture, so we'll have to find a way to add that back in as well. So up to this point, we've largely focused on fixed effects in these things, but the same issues show up in random effects, just to remind you. So those of you who are planning on staying in the a univariate MLM world with time-varying predictors, this one's for you. You can set up your model using person mean centering for your time-varying predictors or constant centering, it's up to you. However, when it comes to estimating the random slope, you don't get a choice. It has to be the person mean centered variable that goes in. So on the fixed side, if we have a variable centered level 1 predictor, so we've subtracted the person mean, we know that it only contains within person information, therefore its level 2 slope can only be between. If we have the original time varying predictor that has both between and within lurking in it still, its level 1 slope will be smushed if you don't add the person mean. But once you do, it becomes within, and the contextual slope solves the problem to get to what between should be. So these two become equivalent with respect to their fixed effects. On the random side, there is no analog to this. So really, in practice, your only choice is to use person mean centering for the predictor that has the random slope, even if you didn't do it on the fixed side. So if you use variable centered, person mean centered level 1 predictor, the level 2 random slope variance will only capture between person differences in that level 1 slope as intended. Everything is fine. Behind the hood, what you're saying is there's a quadratic pattern of heterogeneity of variance along the level 1 predictor only. If you put the random slope on the original OG time varying x, then you are actually doing two things at once. You are saying that the extent of slope heterogeneity across people is the same as the extent of intercept heteroskedasticity across the person mean. And yes, that sounded like word salad. Essentially if you picture a plot, and on the x-axis is your within level predictor, like time, for instance, last semester, the model then predicts once you have a random slope that the variance changes quadratically across time. So let's put in within person x here instead. A smushing problem on the random side says that this pattern across level 1 time is the same as what it would be across the person mean. So you're introducing heterogeneity of variance at level 2 that is assumed to be the same extent as what it is at level 1. That can screw up your estimates of your random effects, which can screw up your standard errors, which can screw up your p-values. So there is potentially a solution of adding in a contextual random slope. I have gotten it to estimate in exactly one data set when I've tried this. So I'm not sure if it's a solution yet. But that's why that was in examples 2 and 3 as an interrobang for the equation, because the notation system does not anticipate the idea of a level 2 random slope. So long story short, if you're doing person mean centering and univariate MLM, it has to be that way for the random slope. You can choose to have an OGX with the contextual slope at level 2 on the fixed effects if you want. Okay, I know that was a lot. Do you want to hear any of that again or ask questions? I can say it more slowly. More slowly? Yes. Okay. So on the fixed side, we can do within or between, or we can do within or contextual. And we can get back and forth, right? The reason that we can get back and forth is that it's possible to add in a contextual slope to unsmush the level 1 slope. There is really no possibility to do that analogously on the random side. So you would be estimating a smushed random slope if you did it with OG level 1x. And what it means on that side is that you are saying the same amount of slope differences across people is equal to the amount of heterogeneity of variance, heteroskedasticity across the person mean. There is a paper on your reading list, writes in Sturba 23. As far as I know, it's the only paper on this topic. They were the ones to finally figure this out, so kudos to them. So I would read that if you're curious, and literally my hands are making the plots in their picture. So, does that help at all? Okay, what's your take-home message? That's what I want to leave you with.
Just use within person and person mean centering.
Yeah, use person mean centering.
Just do that and move on with your life.
That's right, correct. Use person mean centering and move on with your life. But if you don't, here's why. And you can have a hybrid model. Like you could do within contextual for your fixed effects, but then use person mean centering for your random effects. I did that in the previous examples. You can sort of mix and match these things. Okay, So then boxes, univariate MLM, go to circles, camera 1, camera 2. Welcome to MSIM, latent centering. So it seems straightforward, but then we get into complications. Like if I'm doing it this way, if I wanted to know, say, if the effect of the person mean, meaning my between person effect of whatever x is, let's say the effect of being a more stressed out person, do you think that might vary by something like age? Like maybe undergraduates have a different between person relationship between stress and well-being than graduate students. Could that happen? Yeah. So how would I build that into my picture if I wanted to know if this slope right here differed by age? What's that sound like?
Sounds like another box up above with arrows.
Yeah, like if I wanted to show it in like a conceptual way, it would be like an age box with an arrow pointing to this arrow. Like people do that as moderation. That's not an estimable path diagram. It's a conceptual one, but I can live with it. It would actually be properly shown with a box of person mean by age, and then that would have an arrow in there, okay? And we could do this no problem, right? We don't even have to build the column in our data set. We could just say age by person mean as an interaction term, right? No problem. Now how do I do it? If the box becomes a circle, what kind of shape is a box multiplied by a circle? It's not one. A rounded box? I don't know. A trapezoid?
It's a square with rounded corners, which is not actually a square.
Yep.
I found out.
It's not a square because it has rounded corners?
Yeah.
What's it called?
I don't know. My son's first grade teacher didn't tell me that part. She just said that the triangle with rounded corners is not a triangle.
Okay, so we have a first grade math authority that rounded squares are not squares, but we don't know what they're called. Okay, well, I would live with that for this, but the idea is that you have to have some kind of latent variable interaction is what this becomes. And that is indeed a thing, but it is much harder to estimate, and you could probably have maybe one of them in your model at the same time. So like practically speaking, the translation from observed variables to latent variables has a lot of consequences in terms of what can happen after that. Latent variable interactions would be a big one. We'll see that in an example. Okay, so this is the baseline of where we're starting from. But now we got to get time into the picture because we're talking about contexts in which there are individual differences in change over time in Y and likely in X as well. So the good news, those of you who are doing person mean centering and wanting to getting on with your life, okay, if you try to fit growth models for your time varying predictor, so you see if it has fixed change over time, you see if it has random change over time. If it has fixed change, fine. If it has random change, stop. You cannot do person mean centering. If it doesn't, you're fine. So if your time varying predictor itself changes over time, but the change is only fixed, it's the same for everyone, you're fine with person mean centering. Because it works the same way as in standard regression. If I have time as a predictor of some outcome, I have within person X as a predictor of some outcome. The slopes that they are given are going to be their unique effects controlling for the other. So any time trend in the time varying predictor is essentially controlled for by putting time in the model. So you're fine. There's only between person intercept variance being represented by the person mean, within person residual variance being represented by the within person deviation, and you're good. If not, if your time varying predictor itself needs random change, there are individual differences in what happens to time varying X over time, then this person mean strategy cannot fully separate out what's between and what's within. And that's because there's two kinds of between. So if we go back to last semester for a minute, a random intercept only model implies what in terms of patterns of change over time?
Everyone changes the same.
Everyone changes the same. That means that the variance is the same over time, parallel lines, right? There's only one kind of person dependency, and it's constant. That's what a random intercept model says. There is one correlation of the observations from the same person, regardless of how far apart in time they are. Once we add a random change slope of some kind, and by the way, I'm deliberately changing my language to say random change instead of random slope, because there's going to be 18 different kinds of slopes in these models, and it's very difficult to keep track. So we need a better word. Once you have random change, that implies two kinds of dependency. There's a constant layer that comes from the intercept, but then there's a non-constant layer that depends on what particular occasions you have. And that means people differ from each other in two meaningful ways: how they start, how they change. So then this idea of between versus within falls apart. There's two kinds of between. And if you don't take the between out of the within, it's smushed, but it's smushed in a different kind of way. So let me show you a picture to hopefully illustrate what some of the consequences of this. On the left-hand side would be predictions consistent with the random intercept only model. Everybody, no change is the same. On the right-hand side would be predictions consistent with a random linear model. Some people go up, some people go down. But if we think about what between means, like if we compute a person mean, if we do it on the left-hand side, I'm not really losing anything by thinking of this as just the mean, right? They stay the same distance apart. Like this person is the highest, this person is the lowest, and it stays that way. So the person mean is a decent proxy for this. What about here? If I take the person mean, which is essentially like this occasion, that's only one version of between. This is like the intermediate where these people are all close together. Individual differences would predict things differently if I captured them at time 12 than if I captured them at 18. There's not a single between person intercept that's unequivocal. So it matters. Like, do you want to have age 12 as your intercept and see what predicts individual differences in little kids, or age 18, big kids? That's a choice. They're different things, though, is the point I'm trying to make. So that's one downstream consequence. If you have individual differences in change in your predictor, what you're thinking about as between at level 2 needs to become more specific. So we end up with something that's going to look conceptually like this. Instead of one green circle for between, we got to have at least two. Two latent variables, intercept and change. At level 1, one latent variable for residual. And note the subscripts, U1i, U0i, they've picked up y's over here and x's over here because they're different things. So in these multivariate models, you'll have to find some way to notate which terms are predicting which outcome. Up to this point, we've only had one outcome. We didn't have to notate that. Sometimes I do superscripts, but that gets confusing because they look like exponents. Sometimes I just stack another subscript on the end. That's what I'm doing here. I don't think there's a single right way to do it. So long as you're internally consistent and you define your system of notation, you're good to go. But this is where we're headed, conceptually. So if I have a time-varying predictor that itself changes over time, I could still have a between-person intercept relation. I could still have a within-person residual relation, but then I can also have these change relations. Go for it.
And the change variance is what we formerly thought of as slope variance.
Yeah, change variance, this is random slope variance for time specifically. So random change as opposed to random slope. And I may have an analogous one. Like if this circle is here on the x side, that's when you can't do person mean centering anymore. Because otherwise this circle is lurking inside the purple one. Yep. So if this level 2 between person change variance of x needs to be here, that's the point at which you cannot do person mean centering anymore. Because person mean centering would leave it buried within the purple. So where I'm building up to, and this will be my last point since I know our heads are full and it's 1:40, where I'm building up to is a second kind of smushing problem. What we've called smushing up to this point is separating between from within at all. I'm going to call that intercept smushing. Now we're talking about further going into what we called within and seeing if there's yet more between still lurking in it. And that yet more between still lurking is because of individual differences and change over time. If I don't pull this green circle out of this purple one, then I got two variables in one, got one fixed effects instead of two at a minimum, and those things are smushed together. So the paper that's under review that's on your reading list, I have a more extensive simulation demonstrating this problem. And in chapter 9 of the book, I have a little one. I'm going to talk about that next time probably. But time smushing is the new idea here. Time smushed effects. Random slope variance for change over time embedded in the residual. That will cause bias in what the residual within person results become. Okay, how are we doing? Hanging in there? Okay, we're gonna keep talking about this and talking about this and talking about this for like the next month, okay? I think that's about how long it's gonna take. And I expect that a lot of you will be needing to understand this to work on your projects. So that's why we'll talk about it. Any questions you wanna talk about right now or comments? No, everyone's like, I'm so overwhelmed right now. I can't even. I'm with you. I'm with you. Just remember my catchphrase, though. Not happy garbage day, but if this were something you could teach yourself by Google University in 10 minutes, this would be a waste of your time and money. That's my catchphrase. Okay. All right. Let me know if you need anything. Keep working on your homework. I'll see you Thursday on Zoom at 12:55. Okay. Thanks for being here. Bye for now.